Hello everyone, welcome to our next session on emergency apps. My name is Tadas Maroscikas, I'm the Deputy Director of 112 Lithuania, and I'm excited being and meeting you in person, finally. Hope we will stay safe and sound afterwards. Let me, as I mentioned, that the topic is on emergency app, the session, and we have three speakers today. Iratxe Gomez from Atos. We have James Winterbottom, who is not in person here, but his speech will be recorded, so he's substituted by Frequentis from Deveryware. And we also have Wolfgang Kampichler from Austria, from Frequentis. So I'd like to invite Iratxe to start her presentation.
Thank you, Tadas. Do you need this? No, I think it should be okay here. Well, hello everyone, and thank you for the opportunity of presenting what Atos offers in terms of emergency apps. Although what I will be presenting is not the typical citizen side of the apps, it's the first responder side of the apps. So, sorry, I'm not used to doing things without the mask anymore. So, as I was saying, I will be speaking about the other end of this spectrum in terms of apps, because so far we've been talking about the standardizing the communications using emergency apps from citizens to Psaps, but we haven't talked that much about Psap to first responders. So, a brief introduction. Atos is a big company, it's a multinational, we are a lot of people, we do a lot of things, and one of the things we do is, in my division, Big Data and Security, we do public safety solutions and services, and these parts of the public safety solutions and services include Psap solutions, it includes mission-critical communication solutions, it includes communication solutions, multi-channel communication solutions, you name it. We do a lot of things, but I will focus on public safety today. First point in order, why would any first responder need an emergency app if they already have the means of communicating using radio channels or handheld radio and things like that? Well, first, an overview of what we understand as public safety. Public safety is not just the Psap, it is also the network, it is also the citizen side of things, it is also the first responder side of things, and it's also an extension to a lot more aspects of life when we deal with public safety situations. And what I would like to focus today is on the apps to be used by people on the field to respond to emergency requests, be it in a normal incident, everyday incident, and also in crisis situations or disaster situations. So, first of all, the key need of first responders is to be aware of what is happening and where, and what their intervention would be. And for that, they will need a mean to gather from the relevant stakeholders the information that will help them to solve the situation or to request additional means to solve the situation. And they need this information in a standardized, secure, and agile way. I mean, they do not need to be waiting for the information. They do not need to be requesting for updates and additional data. Everything should be coming at once, in near real time, if not possible in real time, and also with as much rich information as possible. And also, it needs to be bidirectional. So the traditional way, using handheld radio devices, it limited the amount of information they can share. It limited also the means to share that information, because voice was and is often the only way of communicating that information. And then, of course, if they want to share rich data with the Psap, they don't have the means to do that using traditional handheld radios. There are new needs, and as I just mentioned, one of the new needs is to share rich data with the Psap. Be it medical services to share medical data, be it firefighters maybe to share situational information with a command post, or be it police officers sharing traffic accident data so they can share it with the other organizations participating on it. And nowadays, as everyone carries one or more smartphones, and often in ambulances, fire trucks, police vehicles, there are also tablets available, why wouldn't we allow them to have specific apps, dedicated apps, that allow them to get good communication with their Psaps, their command posts, and so on? And if it's an app, it would be an app dedicated to their needs. It would be an app that it's built for their and for the needs, taking in consideration their specific needs. And let's consider also other stakeholders that often participate in emergency situations, the volunteers that are not the traditional staff of the emergency services, the volunteers that often provide their own equipment in this form of smartphones and so on to the operations. They could also install the apps that other responders are using in their own devices, of course in a secure and controlled way. And my next point is about how would those applications work in the field. So based on the needs of end users, we are ready to provide different types of applications. One of them is an extension of the actual CAD in the Psap. So it's a solution that is part of the CAD solution, that it's installed in the form of an app in smartphones and tablets. Another one is an extension of the mission-critical communications components that we have in the Psap, the dispatcher solutions, the multi-network dispatcher solutions that we use in the Psaps. And that's an extension in the form of an app, so they can communicate using mission-critical push-to-talk or mission-critical data and video from the field into the Psap. And then we also provide simpler professional mobile radio-like apps that just focus on PMR communications. The first one I mentioned, it's the extension of the CAD solution that we offer. Our public safety CAD solution is called GEMA, which stands for Global Emergency Management by Atos. Sorry, it's the name we chose a few years back. And actually, the app users are linked to dispatchable resources. So if we dispatch an ambulance and we have crews in the ambulance carrying the app, those app users would be linked to the ambulance itself, and the ambulance itself would be a dispatchable resource in the CAD system. Same with firefighters, same with commanders in the field, same with other people carrying the apps. And if it's in the form of a tablet, it could be the tablet carried in the fire truck, it could be the tablet carried by the police vehicle or the ambulance and other vehicles. So what we provide is, as part of the CAD, specific users and roles that are linked to the mobile users with their own credentials and security built in and configured in a way by the administrators of the system. And the settings of the users and the roles are what define what they can do with the app and what they can access to in the app. It's important, first of all, to have traceability of the resources in the Psap. So we need to be able to track the app users. It is important also to share both ways, location and the classification of the events, what's happening and where it's happening. And it's important also to be able to add rich information like victim data or pictures, videos, or documents that could be sent from the field into the Psap as well. What we provide is two types of main users for the app. First of all, the first responders as such, and they can be a variety of first responders from different fields of life, but also a tool for the commanders to have situational awareness. And the situational awareness comes in the form of seeing what's happening in an area, or seeing the types of events and the relevant information of those events in that area. The victim management and incident management features are also configurable and extendable, and those are the types of information that, for instance, medical services need to gather about victims and patients in the incidents they participate on. We integrate the same capabilities we do in the Psap part of the solution, like sorry, I'm trying to translate into English, the ICD, International Classification of Diseases, and things like that. For diagnostics, we can also add multiple victims with names or anonymous, and we can provide, of course, rich data linked with the incident, including pictures, videos, documents, and other audio files as well. So, a basic tool for receiving data, but also for transmitting status data, for transmitting updates on the situation, for additional requests of resources, for chatting with the other stakeholders if needed. And this is what we provide as the extension of the CAD system. The second type of application we can provide to you is one that's called LiveLink MCX Connect, and it's an extension of the multi-network dispatcher solution that we have in the mission-critical communications area. And it is compliant with a lot of standards, of course, in terms of communication and mission-critical communications, including ETSI and TCCA and 3GPP specifications. And it is including push-to-talk, dynamic group calling, emergency calling, and you can read. I mean, I don't need to read everything that's on the screen, but it's mission-critical specific features that includes recording, geolocation, voice recording, geolocation, and so on. What's important for us is compliance with the standards, compliance with the market standards and with international standards, not just in Europe, but also outside of Europe. And for that, we have experts participating in the standardization organizations as well. Part of the roadmap within this mission-critical communications area is to add more and more features into the mobile apps, and that includes analytics, video and picture analytics. It includes the user location is a basic feature that it is already available, but it's advanced user location when they move or they go indoors and things like that. And then image processing is, and video calls is one of the features that's being currently implemented. More things. We can connect accessories and things to those devices. We also provide tools, not in the form of software, but also in the form of hardware and accessories for mobile devices, like ruggedized handheld devices and so on. And we can connect multiple things to that. As I mentioned already, the multi-network dispatch solution that we also provide in the Psaps. We also provide gateways to several networks, and we can connect additional channels to these types of apps. What's important as well is to be able to integrate additional technology. We don't want to offer just a standalone application that cannot interact with anything else. It is important to be able to extend and to be able to add other features into what we offer. And for that matter, we can provide network communication, private network configuration aspects in the field. For instance, we can connect to drones, images, and present that information in the mobile phones. We're doing that not just in the public safety area, but we're working also in the defense areas and restricted police and defense projects. So there's not much more I can certainly say about that at this moment. But yeah, going back to this slide, what you can see is we do have network extension capabilities in the field. We can provide bubbles that allow first responders in a certain situation to extend, to build to extend, sorry, to create private networks in the spot and to be able to communicate in case the communications drop. And yeah, going again for what we've learned. I think the main messages I wanted to give to you is information between the Psap and the app users, be it in the form of a smartphone or in the form of a tablet or whatever, need to be exchanged securely and using a standard for interoperability. If the standards don't exist, we need to build them. And we need to be able to build them in accordance with the needs of the responders. All those apps that are used or maybe used by first responders need to be designed both for smartphones and tablets, because the tablets allow for much more richer information to be presented. If, for instance, you have a medical personnel in the field and they need to provide advanced medical information with images of the cardiac monitors and things like that, they will need bigger screens than a smartphone to see the information properly. And then, of course, traceability of rare responders, it's important. We need to be able to trace responders at all times, and even indoors when possible. And these parameters need to be configurable to allow also for privacy regulations and so on. Integrating new features need to be easily done, and that's one of the points that we work on. We are integrators as well as developers. And then, of course, if volunteers are part of your organizations and they need to be using the same apps you use, we need to be providing the credentials that are specifically for them and that are adapted to the needs of the organization. And that's all I wanted to present, so time for questions.
Thank you, Iratxe. And any questions from the audience to Iratxe? 1, 2, 3. No questions?
Yeah, there's one in the back.
Oh, yeah, sorry.
Sorry, maybe I've missed it, but since when are you live with this app? With these apps? I don't know.
Yeah, well, some of the apps are already live. The mission critical ones are already live in defense projects in France, for instance. The extension of the CAT is currently being deployed in a project in Spain that's going to go live very soon, in a couple of weeks. So the first phase of the project is going to be live in a couple of weeks, but the app is coming as a second phase as well. But yeah, for Android and iOS versions of the apps. Thank you.
Okay, we can take one more question if someone wants to ask. No. Thank you, Iratxe.
Thank you, Tadas.
Ovations to Iratxe. So let me introduce our next speaker. James Winterbottom will be addressing you virtually in the recorded video, and also on the stage will came Bertrand Cass from Deveryware and his colleague Javier Cabas. Is him coming?
Yeah.
Okay. Okay.
So good.
We will be speaking about PEMEA topic and.
Yes. So unfortunately for travel restriction issues, James is not able to come today, but he wanted to be there. So he had time to record the presentation we are going to hear, and so we'll be able to answer your questions just after the session. Okay, so.
Hi everybody. I'm really sorry that I can't be there in person to deliver this presentation, but the current international travel restrictions make that next to impossible. However, I will have two colleagues, Bertrand Cass and Javi Cabas, up on stage to answer any questions in the closing minutes of this presentation. My name is James Winterbottom, and I am the Chief Architect and Product Manager for Deveryware's Gale Emergency Services product line. I've been involved in emergency services since 2000, starting in the cellular space with routing calls and delivering accurate location information through to Psaps. I then moved into the IP emergency calling space and worked heavily on the NEENA I2 specification, the NG112 NEENA I3 specification, and then IETF, Atos, and ultimately into 3GPP and ETSI. So I've delivered these services, I've supported these services, I understand these services, and they're really all about making the public safe and ensuring that the call takers and the first responders have all the information they need in order to ensure that we end with a positive emergency outcome. Today I'm going to take you on a bit of a journey. That journey goes back to when telephones first appeared in the early 1900s and very quickly became the primary means of communication. You would find a phone, pick up the receiver, it would go through to an operator, you'd tell the operator what service you wanted and what your issue was, they'd put it through to the police or the fire or whatever, you would tell them where you were, and they would come and find you and give you the assistance you needed. We then had automatic telephone exchanges where you just dialed the number, it went straight through to the Psap, you told the Psap call taker what your problem was and what service you wanted and where you were, they passed that information on to the first responders, and you would get the help you need. Then, a little bit later, we ended up with something called calling line identification. So, in the calling line identification, your telephone number would be pushed to the Psap at call time, and the call taker would then push that into a database, and out would come your location, or at least the location of the phone that you're making the call from. And that information could then be provided to the first responders so they could find you quickly and deliver the service you wanted. Then came the mobile telephone, where you didn't even have to go looking for a phone. You reached into your pocket, you called 112, it went through to the emergency call center because the network could generally find you well enough, but that location wasn't good enough in order for the Psap to be able to dispatch anybody to you, so you needed to know roughly where you were in order to get that information through to the Psap so that the first responders would be able to find you. But all of these are voice-based services. What happens if you can't speak or you can't hear? Back in the 80s, the fax machine was pretty special and pretty popular. So what happened there was that a number of the member states said, use fax machines. And that's still their preferred mechanism for getting emergency requests from those people that can't hear or can't speak. Of course, fax machines are not very easy to find these days, and they're also pretty heavy and bulky and not really very mobile. You could always use a teletype machine, where you pick up your phone receiver, you put it onto this special box, which pushes your call through to a dedicated call center, and then you can type your emergency request into that. Again, not very portable and probably not very quick, and definitely requires registration and a dedicated call center to be able to manage those kinds of things. You could always ask a friend to help you. Well, that's all good, but these aren't really very conducive mechanisms if you're in a really urgent emergency situation. These systems just aren't meant for that. So, what are the options? Well, we could evolve everything to be IP-based. So, using the internet, we know where we can get all of these services. And that's the basis behind the NG112 solution, which is based off the NG911 solution from the United States, which kicked off in around about the mid-2000s, been developing ever since. So it's quite a mature architecture. It's got lots of nodes in it that are well understood and well defined. So it really is quite an amazing system. It can do a lot of things. But how do you connect to it? Well, you pick up your new fancy smartphone, which supports this thing called VoLTE, and you make a call and you talk to the... and there's the problem. You talk to the Psap, because the V in VoLTE stands for voice. So these services are delivering voice services, which isn't really what we were after. So what about the text and video that we wanted? Well, yep, you can get video over LTE. It's in something called VI LTE. It's just not particularly widely deployed. And the other thing that happens is you've got these things called rich communication services, RCS, which the operators can also put into their network. But again, not being widely deployed. And so what about the people with hearing and speech disabilities? What's happening with them? Well, the reality is there really isn't a big market driver for these services to be deployed, so a lot of operators are not deploying them. And that means that the services are going to be pretty hit and miss, even for where they are deployed. So what are the solutions? Because, the people with hearing and speech disabilities are being left behind again. It's unfair, they're left behind, still long call answer times, really not satisfactory in emergency service situations where things are urgent, and also contravenes the current Universal Service Directive, which calls for equal access for emergency services for people with disabilities. So what can we do about that? Well, let's give it some thought. We could make some really nice apps to support this. And that would be pretty good, wouldn't it? Because we've got all of these really smart devices, so smartphones, which are getting bigger and bigger in terms of their screen size, so that we can do some nice things there. We've got smart tablets that have got lots of comms. We've got laptops, we've got desktops, and we know that the same applications can run on all of these and go through the same service. So why can't we use those? And they can deliver things like text, they can deliver videos so that we can do sign language if we need to, they can share files, they can do all of those sorts of things. So truly awesome. Apps are obviously the answer for this, aren't they? So I can take my app on my smartphone or my tablet and I can take it with me anywhere I want to go. I can take it to the south of France on holiday with me and I can make an emergency call if I get into trouble, can't I? Whoops, sorry. Most of these apps suffer from the same thing that early emergency apps suffered from. They're designed to work locally. And that is a problem because it means that if you take it away, it'll just try to connect to the local Psap, or it might be smart enough to say, I'm not going to try at all. In which case, you're really back to where you were before. You better get a friend to help you, or you need to have one of those other devices and mechanisms in order to be able to make your emergency call. So it's not very useful. So what are the options? Well, about 5 years ago, we started some work in EENA to help people that had developed applications, and specifically PSAPs and app providers that had developed apps to deliver accurate location through to PSAPs, because the location information that they were getting from mobile phones wasn't good enough to dispatch first responders to. So a lot of these apps sprung up all over the place, but they were very regional or they were based in countries and they didn't roam. So we started an initiative to make these applications roam. We also noted that there were demographic applications within this space that catered for particular types of users. So there was a hiking app which would, if you called emergency services, would push through the path that that particular hiker had taken so that you could more easily find him. There were also cases where people had heart conditions and things like that, so you were able to push defibrillator information down to them. So we didn't want to lose that capability, and we came up with this thing called the Pan-European Mobile Emergency Application Framework, or PEMEA, and it was invented to roam. That was its purpose, was to roam and make these services available in multiple PSAPs without having to have multiple applications. Because it was a new framework, we built it with security in mind, so we put all of the interfaces into and out of this system in a secure fashion. This made it quite easy for us then to comply with, or to conform with, the General Data Protection Regulation put out by the European Commission. And PEMEA does have an official GDPR conformance statement that you can download from the EENA website. We also have done a lot of development with PEMEA in various EC-funded projects, which have allowed us to develop advanced services. So we have an advanced instant messaging chat service that's multi-party and supports language translations on the fly, which is very useful in Europe where you move around from country to country and the languages change. So you can type your messages in your language, they'll go to the PSAP in the PSAP's language, they'll type in their language and you'll get back the response in your language. Really good. We've also got Multiparty Rtt, which is currently under deployment. We've got audio-video services based on WebRTC, and we have a couple of flavors of those. We have file exchanges going on. And of course, we can support accurate location information with location updates and user information. And all of those things are currently undergoing deployment or have already been deployed. As I said, we did this thing initially through EENA, and then we took it into ETSI, and so we now have an ETSI specification, TS103478, which defines PEMEA signaling, all of the PEMEA signaling and the base services around accurate location information, location updates, and user information, and it provides extension points for the other capabilities that we can see there on the screen. So what we end up with is an absolutely awesome solution. We can do these things. And we formed the Premier Consortium. And Premier Consortium is really a group of app developers and vendors and emergency service professionals and academics and people that are interested in the wider promotion of PEMEA and the various services that it can support. And a number of the people that are involved in, or organizations that are involved in this consortium, have actually deployed PEMEA networks. And one of those PEMEA networks was a customer of Deveryware's, and we deployed that network in 5 weeks. So these systems can be deployed really quickly. The advanced services are coming on board. There are about 4 or 5 current developments underway, and we will see a lot of those things go live by the end of Q1 next year, and those will support all of those multimedia services that we saw on the previous page. So the PEMEA Consortium is really all about developing high capability, high mobility applications so that they can roam across Europe to deliver emergency services for the public and deliver all of these additional capabilities for the PSAPs and the call takers and for the first responders. So what's going on and how do we interwork all of this with NG112? Well, NG112, as I said, is quite mature. It's got really cool things in the network that we can make use of in PEMEA and reuse, so that people that are deploying this infrastructure only need to deploy it once and provision it once, and they get multiple services using it. We started the work in ETSI under TS 103755, which is currently a work in progress. But the main things we're looking at there are around the emergency call routing function, or the ECRF, which is really cool. This thing takes location information and the type of service you want and maps that into a destination. Now that destination may be a Psap or it may be a first responder, depending upon how far through the call process you are. But the concept and the mechanism for that works equally well whether it's going through the ESINet for NG112 or whether it's a PEMEA-based call. We're looking at the location information node, or the location information server as it's called, which provides the call takers with a common means of accessing location information. So they don't care where that location's come from. They don't care whether it's come from AML, whether it's come from the operator's network via MLP, or whether it's come in-band with the call, or whether it's come from PEMEA. They don't care, they access it, they get that information, and they can see how good it is. We're also looking at how we can reuse some of the policy routing functions that determine things like, can that particular Psap handle the type of service that we want? For example, can it support a particular variant of sign language? Is it congested? Would it be better to push it to a different call center? All of those sorts of things we can look at and provide as well. And then finally, we're looking at how we might get calls into the Psap call queues so that we can reuse those call queues without having to have different call answering mechanisms. So what we're seeing is NG112 is being fed via the existing or the traditional operator networks and it's delivering high quality voice through those services. And where provisioned, it can provide those other services that we talked about. But what we're actually seeing happening through tender and certainly through the deployments that Deveryware is involved in, those high value add services or advanced services are being delivered through PEMEA and being requested to be delivered through PEMEA rather than through the NG112 mechanism. And this is just a reality. It's what's happening.
Thank you, James, for your voice and slides. And maybe your colleagues would comment or answer some questions from the audience if there is any.
Sorry again for not having James here. It was a question of COVID things, you know. And but we are ready to answer any questions that you may have.
Okay. No? Yeah, okay. Yeah, here.
he expressed himself perfectly well, so no questions.
In the light of what Iratxe mentioned in her app, it requires registration. Does the PEMEA app require registration as well for the user, the general
I didn't understand.
If registration is needed for...
Sorry, because I didn't hear very well. You mentioned registration, right? Yeah. No, the idea is not to the apps don't need to register in Citizen. It should be a global access for everybody. So PEMEA is not considering registration. We have some mechanisms related to the telephone number confirmation, but this is not registration. The service is open for everybody. Yeah.
Okay, Iratxe? Oh,
So,
okay, yeah.
what happens here is we've got everybody as a winner. So these
James?
services are not in competition. They're aimed to share services where they can.
We still have some minutes, so we can continue.
No, it's okay. It's okay.
It's okay. Okay.
And goodbye.
So you wanted to ask?
Do you see any regulation coming out in order to suppress the numerous applications being built at the moment in a lot of countries? So do you see that, because I know that PEMEA has already established in Finland and some other countries,
Yeah.
do you see any faster approach and
Thank you.
PEMEA is putting the things easy in general. So we have seen, and we are seeing every day, many apps roaming across Europe. The idea here is not to have a single app that could use everybody in Europe. The idea of PEMEA is to have multiple apps, as many as they are, as they may be in the market. In, of course, having security concerns and having all the GDPR aspect needed for providing service. So what PEMEA is providing is a framework that allows any PEMEA compatible app to connect with Psap in a secure and controlled way. You may have specific apps to cover a very specific use case, rescuing mountain, for example, or global apps that provide multimedia communication service over the top, like Teams or WhatsApp or any others. So what PEMEA is providing is a standard that could be used for app providers to connect to Psap in a controlled way. Okay? And it also provides a single format for Psap so that they don't need to implement every connection with every app. So with a single connection to the Psap, you have the way to provide over-the-top communication services. Okay? So if we have many apps, it's okay for PEMEA. It's transparent for the Psap. A single connection is okay for all of them.
Okay, thank you very much. Unfortunately, time is over, and maybe... So thank you, Javier and Bertrand and James, wherever you are. And let me introduce our last speaker today, Wolfgang Kampichler, principal scientist from Frequentis. He will share best practices of emergency apps and NG112. You're welcome. You have a mic, okay?
I have a microphone, yeah. Thanks, Tadas. What's the perfect world in emergency communication? Who knows? No calls, yeah, that's really close. I'll show you the perfect world. Oh, no, that's not the perfect world, that's the wrong thing. Just your mobile, yeah? As we've seen in the presentation before, in the future you get the voice over LTE, you get the voice over video, and you have it natively implemented in your device. Actually, you don't need apps. Even if we're going to talk about apps today, the perfect world is you have it in your telephone, you have it in your mobile, you don't need an app, you can directly connect to the right Psap. And this is already out there. Yeah? We had some very nice plug test event and ICE industry collaboration event earlier this year, where we had a mobile network operator joining as originating party in interoperability testing. And we had a voice over LTE call, we had multimedia calls like audio, video, and real-time text being routed over an ESINet using the elements, the core services of the ESINet that James already introduced. And at the end, you need a control room or the control center. And perhaps that's the tricky part here. As James also mentioned, you need the capabilities in the control room as well. So it still needs a little time. Yeah? We have some legal and some regulatory issues to discuss, and there's also operational responsibility that needs to be discussed because several parts or several stakeholders are involved in this end-to-end chain. Yeah? You have the originating network, you have the mobile network operator, you have the carriers, then you have the ESINet, and then you have the Psap. And everything needs to fit together and needs to fulfill 24/7. So it's mission critical services actually. If you want to call emergency services, it needs to work. So a lot of legal, regulatory aspects and operational responsibilities as well. And last but not least, also the operation itself in the Psap. So the call takers will be working with different technologies. It's not only a voice call anymore. It will be texting or it will be a video call. And that changes a little bit the operational behavior in the control rooms. On the other hand, as I mentioned before, we have the originating devices. And here we have 3GPP standards, for instance, that are already describing voice over LTE and emergency calls, which means you have to have the certain capabilities in the end device. And recently, I talked to a mobile network operator in Austria, and what we've heard is that they already started testing such emergency calls, but they found out that different devices have different capabilities. So even if there's standard, it needs to be rolled out, and all the devices need to have the same capabilities in order to provide, or to be the originating device when connecting to an NG core service or ESINet, which means providing location with a good accuracy, perhaps by value or by reference, depending on how the mobile network operator system works, and also providing the capabilities to have multimedia calls ready. On the other side, we have these core services. I will talk about them a little bit later, and I see here Peter and Christina. We are working actually in the same ETSI standards group, and we are defining those things of the core services, and also the interfaces towards the next generation Psap. And since I'm with Frequentis, I'll invite you to find out more and visit us at the Frequentis booth to see the latest technologies regarding multimedia data location in a next generation control room. The perfect world also needs core services, next generation core services to be accurate. So the usual suspects are here: the emergency service routing proxy, the emergency core routing function, the location information service, and the border control function. So the guy fighting against the cyber attacks to the right. And the good thing here is they're already standardized. As I mentioned before, there's an ETSI working group, a technical committee actually, DCMTEL, taking care of the standards. We also have our friends in the US. The NENA IS3 specification is quite aligned with what we have in Europe. We heard this today in the morning from Brian. And we have done a lot of interoperability testing already. So we had plug tests 4 times in Europe, just putting all the stuff together and testing how the ESRP works. So the first guy, the ESRP, that's the signaling part of the core services. So it does the, let's say, signaling plane implementation, so it's session initiation protocol, and it interconnects with an ECRF, which does the mapping for the further routing. We have tomorrow, I guess in the afternoon, a session where we'll also talk a little bit about the LIS or the location in emergency services. Just join that one to hear a little bit more about how location information services work in next generation emergency services. Last point, we have also conformance testing. So recently we started an initiative at ETSI, testing task force that works on defining the conformance test tools that can be used in order to check those guys, to see, okay, is an ESRP conformant to the standard? Is the ECRF conformant? Is the LIS conformant, or the PCF? So there's a lot of work in progress, and let me again mention there are products out there, so you can find them and you can start implementing the core services. And that gets me to next generation core services and the applications. How do the things fit together? So if the application implements those interfaces I mentioned before, like written here, DS103479 or DS103698, which is a lightweight messaging protocol for emergency accessibility, then you can easily interface with an ESINet, with the core services. And you get the standard signaling and media plane. So there's no other service needed, just implement that interface, connect to an ESINet, and you don't have to take care about the mapping and the routing. It's done within an ESINet. So just interface with the core services, with the infrastructure, and you can implement apps, or you can look for apps for specific user groups, for instance, and the core services will manage to provide the mapping and the routing and to connect your application to the control center, to the right Psap, depending on the location information. So I would say it's an open ecosystem done by standards, because everyone can actually integrate or contribute, and as Iratxe mentioned in her presentation, it's very important that you have this interoperability. So you need to implement standards, and that's a way to do even for apps. So you don't have to create your own ecosystem and create a new silo. You can just interface with an ESINet. And on the other side, for the control rooms, there are different options how to implement. So the coolest stuff would be to have the right interfaces, also conformant to the definitions of the NG 112 specs. And that would allow you to, let's say, start small, perhaps just with an app at the first place that interfaces with the ESINet and also interfaces with the control room, and later grow, but learn a lot. So we did that in Austria 2 years ago, starting with a small app, small user group, but there was a lot of lessons learned, how to run an ESINet, how to interface with different Psaps, and how to manage everything that it works. So that is really a cool opportunity to start with apps. And that's just one thing I would like to mention with apps, always also referring to the perfect world. For apps, you don't get, because it's over the top, you don't get the special treatment at the radio access if you do this with a mobile device. So if this is part of your end device in the firmware, then you may get higher priority if you do an emergency call. You can't do that with applications. So that's a really sad drawback if you do it over the top. I mentioned this kind of integration pattern. So what I do not like is the first one, this just creating new silos. So if you have an application, you have a backend, you manage everything with the application, and you directly connect to the Psap, which means on the one side, you have to take care about the routing and the mapping, which actually is done by the core services. And on the other side, the control room would have to implement with different interfaces, with different applications, which actually doesn't make sense. So that's kind of anti-integration pattern. So look into the core services, the core specifications, and perhaps do it that way that your application backend or someone who would like to sell applications to a control room connects with the ESINet. So that would allow different types of applications and also different types of technology. So sometimes, as James mentioned, it's not easy to implement those things. But if you say, okay, there's one point, which is the backend that interconnects with an ESINet, then I may use different technologies on the front end. So even WebRTC or HTTP-based solutions would be possible. Just from the front end to the back end, and the back end itself does the secure and standard-based interfacing with the core services and with the ESINet. So again, open ecosystem, because everyone can participate, just follow the rules in the specifications, find out how to integrate with an ESINet if it's already in place. And for that, because I see some colleagues from Austria sitting here, we will have another session tomorrow. We talk about the NG implementations in several countries. One example, just very quick, is this deaf emergency calling in Austria, which we have in operation since 112 day in 2019, so since February 2019. And it's an application for any Austrian emergency service. Austria is a little bit different. We have the 9 federal states, and each state is responsible for emergency services, and we also have different control rooms. So there's no integrated control room, so we have centers for the fire brigades, for the police, and for the ambulance, which are separated. It changes, so some of them are already integrated, but it's really a different landscape. So it's actually a must to go with or to look for the NG infrastructure, NG core services infrastructure, in order to make sure that you get to the right Psap and you get to the right service. And what this application does is what I mentioned before. There's a specific backend connecting to the front end. We do have a simple registration at the beginning because we were asked by one of the control rooms to make sure that every user can be identified. So it's based on SMS. You download the app, you start the app, you do the verification with SMS, and then you can use the app. So just single registration, and that's it. And the interesting part here is, on the other side, we do have already 3 different control rooms with 3 different vendors. So that is, let's say, thanks to the standard, a really cool thing, because they just implement the standard interfaces and it works with the system. So there's no additional things to be done except looking for the standard, implementing the interface, and then it works. You see here we have the 112 and the 133. It's the police service that gets connected to the police service centers. We have 144 or 122 for the fire brigades, 140 for the mountain rescue, 144 that gets to Not of Niederösterreich, so they were the first partners joining in. And in the next weeks, we have a go live with Vorarlberg. And there's another technology, so that, thanks to standards, it's quite interesting and quite cool stuff to see how this interworking works if you just look at your standards and the standard interfaces. Here is also important this peering with the ESINet. So there's also a secure connection. We have certificates being exchanged. So the app backend is kind of trusted service provider that interfaces with the core service, and that can be a kind of baseline or Blaupause for other services that would like to integrate, like a web service provider could do pretty much the same. Finally, some ideas for the open ecosystem I've mentioned at the beginning. So we had a very interesting project, Celeste, and that already showed different applications integrated in different countries with an emergency service IP network, and on top of it also a forest guide to make sure that this interoperability between different ESINets also work, which means that if you connect to your national ESINet with your application, the ESINet and the peering of ESINets make sure that you get connected to the right Psap. So if I'm roaming into another country with my Austrian application, it would still connect to Austria because there is my application backend. But if I'm, for instance, in Germany, then the ESINet routing, the internal one, would take care to get you to the right Psap in Germany, for instance. So that was part of Celeste, and if you're interested in, just look into the report that is available on the EENA webpage. We have, with that open ecosystem, an interface for media, data, and location. Media means not only voice, it also means real-time texting, it also means video. If that's also provided on the Psap side, you can just simply use it. So that the standard actually doesn't take care about what kind of media is negotiated in a setup. So if it's supported, then you can get those connections. Then there's a new element or another element in the core services which is called the forest guide. So it's a specific ECRF that makes sure that this international peering also works. And we had, I mentioned it at the beginning, a nice plug test event earlier this year where we interconnected with the US ESINet, and we did a lot of such scenarios using the forest guide to do this international routing. And yeah, last but not least, some nice examples for IoT, just integrating sensors. So there's a lot of diversity. It doesn't have to be an app. Actually, it could be some sensor placed at the farmer to take the temperature, to take the humidity, and to create an alarm just by simply messages that are sent to a fire brigade, for instance. So we did that already, so it's really simple to implement, and it just follows the standard. So, as I said before, nothing else needed. Just implement the standard, connect to your ESINet. Hopefully, we see it soon in many other countries. And yeah, that's it actually. I have here a question mark, so perhaps it's time for a quiz. Who knows what lake that is? So this one below, or over there. No idea? Close. Okay, it's in Switzerland, Lake Zurich. Perhaps we get some ESINet in Switzerland. I heard Urs speaking this morning that they are already on the way. Yeah, since I have just 1 minute left, the key takeaways of this presentation: think standards and not silos. Just look for the standards. If you don't find them, ask me or Christina or Peter. And also, yeah, consider that NG112911 standards support media, data, location, conveyance. So you have the full package, and if someone's implementing applications, then just look for it and yeah, follow the standard interfaces and make use of an ESINet. Focus on the application itself. Don't focus on how to get to the right Psap, how to do the routing and the mapping. Actually, applications can help implement the NG core services immediately and gain some experience. So that's the example we have in Austria. So again, just wanted to tell you that we are learning a lot in Austria. We have these core services implemented and deployed, and yeah, open ecosystem, and yeah, finally start shaping the perfect world. Thank you.
Thank you, Wolfgang. Sorry to interrupt you, but I had to be strict. We may have some minute for one question from the audience, Wolfgang. Okay?
Based on the schema that you have shown, the backend of the Psap will be defined by a standard, or every Psap will be defined his backend API, creating a new mess in Europe?
No. The interface to an ESINet is defined. Yeah. So, but what you see is that internally to a Psap, you may have a system from Frequentis, from Atos, who else is providing such things, and internally you may do it in a different way. So that's what I'm mentioning here. So usually you have your interfaces and they are defined. Yeah. So there's a way how to get location, there's a way how to get video, audio, real-time text, and so on. And then within this Psap system, yeah, it's up to the vendor to decide to take this to the core taker.
Okay, thank you, Wolfgang, once again, and thanks all the speakers.